Hi everyone. We're going to try to keep you awake during digestion. So we changed the title a little bit. Before it was a mouthful, and we think this better represents what we are trying to achieve at Rebuy. So I'm Matthieu Pons. I'm still a backend engineer at Rebuy. Sadat will be co-presenting with me. I will be doing the first part of the presentation, more on the inner workings on what we did, and Sadat will present the applications to search. So I'll start with a little bit of context, what's Rebuy, where we come from, then this method that we used, and the applications. So Rebuy is a e-commerce shop. So for those of you who don't know what this is, it's normal e-commerce with a twist. So it has one side that sells products and the other side that buys product directly from consumers. So you can sell your phone, your books, your consoles, video games to Rebuy. Rebuy will evaluate them and then put it back on its platform. What this means, though, is that there is a very volatile availability because our stock is very dependent on what people sell to us, and this can lead sometimes to some problems. So we always have to keep it in mind when we do recommendations or search, and you will see later that we have some problems to solve with in regards to that. So earlier this year, we were tasked to replace our third-party provider for recommendations. So we didn't have a recommender system in place, and we have two main kind of recommendations. The ones that are that you see when you are looking at the products, that would be the bottom ones here, and the ones that you see when you have added a product to your cart. We have other type of recommendations, but these are the two main drivers. One other particularity of Rebuy is our users don't leave a lot of product reviews, and we also have a lot of anonymous sessions, and even more since GDPR. And that means that a lot of the literature you see online about recommendations, generating recommendations, is based on mostly on the fact that you know your users and they've given feedback on the products of the products you have. So when we started, we thought, okay, let's bring the big guns and solve this problem quickly. So we first tried to make embeddings, product embeddings, and this is a very simplified schematic of what we had. So we generated pairs of products that a user either viewed or added to their cart, and then trained a network on this, and then used the embeddings to find similarity with cosine similarity. We had satisfying results, though on some parts of our catalog, the similarities weren't that important. And with cosine similarity, when it's uncertain, it's very uncertain. It's very hard to differentiate between what's more and less similar. So we thought, okay, let's try another approach, and we tried the prod2vec approach, which is word2vec, but instead of using sentences and words, then you use product IDs and sessions. And you let, for example, Gensim in our case, the library, we let it train on all these sessions. So once again, we started with the product view sessions, and then we get also embeddings as output, and we still compute similarity with cosine similarity. And this worked much better. We A/B tested it, and it worked very well, and worked very well on product clicks. But then we moved to add to cart sessions. And as a visual feedback for the add to cart session, we knew already that our goal was, if you add a console to your cart, then we want to show you games and controllers. We don't want to show you other consoles. And in our case, the prod2vec approach was a little too good. That means that even within the add to cart sessions, it still managed to find out that a console is similar to a console. And so you add a console to your cart, and yeah. So I thought, okay, and this also came at a cost for us. So we had spent quite some time iterating on these two approaches, and time also GPUs, and we had the DevOps team helping us setting this up. And so we thought, so the deadline was coming, we needed to replace our provider, and we thought, okay, let's roll back a little bit and try to at least get a baseline going that works and does the job at least on add to cards. And with this prod2vec approach, we sort of had this idea, okay, these sequences, these sessions are the key. When you add the console, after you look at sessions and you see people are adding games. So I'm going to roll back the way we did, and we thought, okay, let's take something simple. Let's take a Markov chain. Here is just as illustration a very simplified, it's a first order Markov chain. You can, even if you raise the order, it will be the same result. And for this toy session of just 2 sessions, it can be clicks, add to cards. If you consider product C, then you get G and H and a 50-50% chance of getting these 2 products afterwards. So you're not that far. If you consider also the co-occurrences, very simple. For these 2 sessions, you get more recommendations out of it, but they are, it's not very specific. Even if you use support and leave to just skim it down a little bit, you're not going to be very far, and you're also going to encounter the same problem, being that if C, in our case, is the console I was telling you about, then it could very well recommend A again, which might have nothing to do with the fact that I've just added a console to my card. So our intuition was this, basically, in one graph, is that something that you do at instant T has a repercussion on what you're going to do after. And this repercussion is going to decay with time. So this is called sequential rules. It's a little bit of a mix of the two. And so if you consider again the product C, then you define a window at which you're going to look after the given product, and you're going to assign weights at each event that happened after that. So in this case, if you take C, you have the window. I think it's pretty self-explanatory, and you get this weighted recommendation afterwards. And G would be the most likely product to be recommended with C. So in the literature, you have different approaches where the sliding window is defined, is fixed, or you're just going to look at until the end of the session with an inverse distance weighing mechanism. And in our case, we did a little bit of, we did some grid search on these just 2 parameters. I tried different decay functions and window sizes, and for add to cart, the window of 10 was doing well, and using a linear decay was also giving good results and making the computation faster. So we use the hit rate to do the offline testing. So I put the provider we had there, just historically, that's what we were competing against. I'm sorry, I don't know, and I cannot tell what they are using internally. This also is the result of the prod2vec on add to cart, so where we had the problem. On clicks, it's different, it's much better. And then this is the sequential rules result. But while doing this, we saw there is an improvement we can do to it, and it's using sequential rules on itself. So this is a user session in that sense, and for example, the user added the product A to their cart and recommended these products. Then it went on and added product B to its cart and recommended this product. And now if we just run the sequential rules on these recommendations, we start to see that C is happening in both cases at a particular place in the session, and now the user adds the product D to their cart that also has C. So instead of showing these recommendations that are not rearranged, then we let sequential rules run again there and rearrange the recommendations in there to better match what we think the user might like based on this on this current session. So this is still considered that we don't know the user, it's anonymous, we don't know their previous browsing patterns or anything. And so we are trying to re-implement that on the spot with what the little we knew. And these are the new results we got, so still some improvements. So hit rate at 5 got better, hit rate at 10 as well. There are other improvements you can do. For example, while you let it train, you can also add TF IDF. So what happens, for example, for us is that the iPhone 6 and 7 are very popular products. And they are going to end up in a lot of sessions. Even if some people were looking at books, they're just going to check the price of the iPhone 6 just to see. And using a TF IDF approach to weigh down these very popular products in sessions, so to boost again to boost the products that are more related to the one they are currently added to their cart. So using this, we tried it out. We didn't see better results in hit rate, but we had also visual evaluation, as we called it. So we generated recommendation, and so visually saw what was the output, and it was better results, but we didn't evaluated it with an A/B test. So the pros and cons, and that's why we chose to roll with it, is that it's explainable. So I was telling during the break before we had this Gensim going, we were trying to explain to our PM why we were showing these recommendations, and it could not comprehend the multiple dimensions that the products were represented in, and it kept saying, you're just counting. But with this one, at least we can go back and explain pretty easily to anyone why we are showing some recommendations. It just does one pass through the data, so it's very fast to train. We train 10 million sessions on not this computer, but a similar one in 10 minutes. You can also write it as a map reduce, so if you have more data, then just throw more computers and it will still work. And it's pretty versatile. So you will see with Sadat that you can throw different things, different kind of sequences at it, and you can still provide a very good, very good baseline results. Some cons, so of course if you don't have a lot of data, like the toy examples that I showed, then it will sort of overfit on it, and then, so you might want to, depending on your approach in your business, you might want to drop these results, or you might think, okay, this is my best guess, and I roll with it. It's item-based, so there is no seasonality in it. It's just not going to recommend different products, different times of the year or times of the day. And it's not good at replaying sequences. So I say this because we also use the mean reciprocal rank at some point to evaluate it, and also in the literature it's done, but we believe that for the use case of recommendations, like this example here, so product A, and then it's very noisy, but product C is always there in the third position, then it will recommend it as in the first position, but it never happened in the first position. So if you try to evaluate it, then it will fail because it's not in the third position after product A. So here I would like to mention Professor Janach, who helped us a lot also in analyzing it. And these are the two papers where this method is mentioned and is also evaluated against other methods. So here, I'm not going to go through all of them, but it's just to give you an example of what you can find in these two papers, and also to show you where it stands. So it won't be depending on what you're trying to achieve, coverage or hit rate is not going to be the best, but for a baseline approach that's explainable, cheap, and fast, we believe it's very interesting. And now I'm going to give the mic to Sadat to present you the search applications. Thank you.
Thank you. Hey, so I'm Sadat. I currently work at Delivery Hero, although I was working at Rebuy with Matthieu during the development of this the system that we did. And now that Matthieu has explained to you a little bit of how our recommendation system works, since I was part of the search team, I had seen a lot of search use cases where I felt that we could sort of leverage some sort of search recommendation and maybe help our users. So like he said, versatile, we basically, so I'm going to talk through these three topics, how we did spell check, sort of collaborative spell check, and then develop this similar search feature to allow users to explore. And then towards the end, we're going to talk about a hybrid of search and recommendations. It's also sort of probably in line with the last week's meetup talk that Renee did in, recommendations and search sort of overlapping now. I want you to take a brief look at this sample here, a user search for something, and see if you can notice the difference, and notice what went wrong here. If you hadn't noticed already, the user basically just forgot one R in the Harry for Harry Potter. He was looking for our friendly wizard. And the results that you see for this query are sort of they're just not interesting because none of them have Harry Potter, what the user was looking for. From the search engine's perspective, I could come and explain to you that what has happened here is basically we found no document with the Harry with the single R and Potter. And so we did a query relaxation step. And instead of an and, we did an or, and we find these documents here. And they all have Harry in their title. And so they unfortunately ranked above Potter. We don't know which term was more relevant, right? And in the end, it leads to a very unsatisfying customer experience. Another very common use case on Rebuy is, if you're aware with the phone Huawei, it's got a really complicated spelling. I oftentimes get it wrong myself. And this user here also probably made the same mistake. And Solar, we did have a spell check enabled, so accidentally corrected this to Hawaii and then shows results for Hawaii. If you try to look into it deeper, they both have the same edit distance. And for our corpus, because we have media as well, the document frequency for the term Hawaii was way higher than Huawei, the phone, which our user was probably looking for, right? So what we wanted to do was collaborative spell check. Elasticsearch, Solar, both of them, they do text spell check. They don't really spell check products. There's also the concept of min prefix, which I feel oftentimes personally is very constrictive. Nintendo is another common query that we've seen on our inside that our users have done. And it so happens that the keys M and N sit next to each other on most keyboards, but this is a query that Solar would never be able to correct. During the development of the recommendation engine, we even tried using Word2Vec to sort of fix spelling errors. And what it surprisingly did was clustered all spelling errors together. So if you gave it one wrong mistake, it would spit out 5 other versions of the wrong mistake, It didn't seem to work. So like engineers, we said, okay, let's go back and look inside our data and see what our users are doing. Oftentimes you see that most of our users, but definitely not all, do make the mistake, the Huawei here, and very quickly correct it. Some correct it immediately, like right here. Some take like a lot of sessions to correct it there at the end. But they do correct it. I mean, this was probably a very resilient user who really did want to find that phone. And even searched for cheap phones, Angebot phones, expecting Chinese, cheaper brands. And this is the sort of, so we said, how do we get this information and this knowledge and spread it to all of our other users? The idea was simply, when Matthieu explained the recommendation system, what we try to do is take these user queries, these sessions, and feed it into the sequential rules method. And to sort of walk you through a very small subset of just 2 sessions, where both of them taken from the previous slide actually, Huawei people, you see the spelling mistake is in this term here, and this is the session of the long user, and applying the terms, you see they get corrected. So if you run through this super small example, you see that we've already been able to correct Huawei with the wrong spelling, but some more information here. We've at least got the correct spelling out here in just 2 samples. Given enough sessions, trust me, we were able to actually correct the entire user query. So we were even able to maintain the semantic relations of the tokens and only replace what the user had misspelled. And it also worked for the Nintendo query. We were able to correct that. The way we sort of implemented this was we had the recommendation engine running on the side. We still let Solar do its thing, let it identify the spelling mistake for us, let it correct whatever it thought was the correct answer, but then underneath we just replaced the query from our recommendation engine. And it gave amazing results. This is actually in production right now, works on the website. There's another use case that I want to, this one, right? Over here, the user is searching for Tom Cruise, and as a search person, like a search engineer, I could tell you that none of these documents are actually irrelevant. I mean, they've all got Tom Cruise in the title. But imagine I'm searching for the movie Jack Reacher, and I just don't remember it's called Jack Reacher, but it's Tom Cruise is there in it. I want to go in there, search for Tom Cruise, and I expect to find movies from Tom Cruise. I get these books. These are sort of correct results, but they're still very disappointing. And I don't know, I could probably just go onto a competition's website and hopefully find what I'm looking for. So also notice that this is a dead end. Either I go back to the search bar and try to fix my search, or that's it. I mean, there's really no other option. So for most users, they probably exit at this point and go somewhere else. We again looked at our sessions and see what users do. And you pretty quickly notice that users who search for Tom Cruise probably saw the same result you saw back there. This guy actually corrected a spelling mistake and then searched for movies that Tom Cruise was probably in. And how do we sort of also translate this, get this information and spread it across our other users? We came up with the concept of similar searches. It's like, the first search was correct, but it wasn't ideal. So instead of just leaving the users dry, we sort of implemented this little widget on top, which suggests similar searches to our users. And these are links, so users can sort of interact with our website. We can help them, and they can help us. And so, if I'm looking for the Jack Reacher movie now, I simply click on it, and I get the Jack Reacher movie. If you briefly look at the similar search bar here, I don't know if you did, but I noticed Lee Child was a very interesting name there. I personally did not know who Lee Child was while selecting this sample. And when I did a quick Google, it turns out Lee Child is the author of a series of books called Jack Reacher, on which the movies are based on. So the system had learned to recommend even interesting things to the users, if you're probably interested in the movie or even a similar genre. Sort of the takeaways that we had from this was we required very little data processing. The only data processing to our search sessions that we had done was lowercasing terms and then sort of dropping a few super long queries. But that's about it. Maybe removing a few special characters that we did not want to consider, like emojis and stuff. But yeah, that's it. And then this was the data that we that we used for training the sequential rules method. And we were able to power the similar search feature. It increased user engagement. We were also, sort of like these examples here, in which we are able to suggest users similar sort of music preferences, or maybe even help them filter their query. Google Pixel would be a very generic term. So maybe you want the 2 or the 3, or maybe the iPhone. It's a super common thing on our platform. Or also over here, it turns out that it even works for synonyms, or expanding query terms. So NFSMW automatically got translated to Need for Speed Most Wanted. That I felt was like super amazing, because that was never our intention. Now, there's another example. I think most of you in e-commerce search have probably faced this. Nothing's really gone wrong here. The user did ask us for a very specific product, the GoPro Hero 6. There's only one of it available. And so we showed them the product, but unfortunately it's unavailable. If you see cough alarm is basically, do you want to set a buy alert for this product because it's currently unavailable. But then there's a lot of wasted white space on this page, and you could have people say, hey, why do you want to waste so much real estate on the website? Can we not show other products that are relevant? We do have this search bar, this similar search bar on top. But could we not probably fill this page up? And that's when the search and recommendation hybrid sort of comes into play. We sort of hypothesized that similar to the way we were having search sessions in which we basically had the queries that the user had put in, what if we embedded products that the users interacted with after these queries? So you see the P hash and then the numbers here. These are actual products that the users interacted with after performing these search terms. This one's highlighted here because he actually made an error here in the Jakob, used the K instead of the C, so fixes it, and then actually interacted with the product. And looking at this session, what we realized is we could probably have an approach in which we can sort of learn the products that go with certain search queries in similar terms to how probably learn to rank works, but without any feature engineering or anything. And we were able to power this. So the idea was, we basically pick out products that were in the user session with similar search terms and boost them or sort of add them to the search result. And this was the end result. The hybrid search and recommendation is still an ongoing test. This is sort of how it looks like. And if you notice, these are all very relevant products that might be of interest to the user. A little post-processing that we do is we only inject available products, so at least the user can act upon these. Going back to the Harry Potter query, using the hybrid search and recommendation approach, we noticed that most people who actually typed in the mistaken query interacted with Harry Potter books. So we've silently boosted Harry Potter novels here in this segment, and makes for a better result, although we still detect the spelling mistake and we allow the user to sort of correct it. This is also another interesting situation in which the user made a spelling mistake with Assassin's Creed, but obviously quality of document and stuff, we did find things here. But obviously, I think if you look at the user sessions, there weren't any products the users interacted with. And here, if you sort of go along with the hybrid search and recommendation, we were able to inject products that actually made more sense to the user's query, actual Assassin's Creed games than others, So that was our talk. Questions, please.
Thank you very much. Right, we have a question already. Very keen. Thank you.
Hey, thank you very much. So from what I take away is that a lot of your results will be very similar items. Is it also an objective for you to introduce some kind of diversity to help maybe for example for Tom Cruise there are books, there are movies, very different kinds of movies, and so from what I see, your results seem to focus on one kind of them. Would it also be interesting for you to think about diversity, and how would you approach that then?
That's actually a pretty good question. So the idea why we went for similar search was to hope, in hopes that, when you directly inject or recommend products, those are very specific products. But the hope for recommending search queries are, we hope that there'd be some diversity. If you looked at the Tom Cruise example, there were a few different Tom Cruise movies that were recommended, but agreed they were all movies. But that's what our users are probably using the platform for. And the way the system is built, we don't actively promote diversity. We're not injecting something like, we're not trying to push Tom Cruise books because nobody's looking for them. We could, although it might be a little hard with the current setup. So we haven't, to answer your question in a short form, we haven't done anything actively to promote diversity of our products.
Thanks, great talk. Do you do anything to avoid like obscure queries where someone's looked for one thing and then they found something else, but it was just one user session? Avoid that surfacing, or perhaps even people trying to inject perhaps even offensive kind of suggestions into your system?
So the one thing that we do is, during the pre-processing that I mentioned, the very little pre-processing that we do filter out queries that are very infrequent, things that show up once or twice or 10 times in a day. It still is not foolproof. It's still probably possible to inject offensive terms inside, and we haven't done anything actively against it, but I assume there could be systems in which you could, figure out during the pre-processing to sort of already remove offensive terms so that they never end up anywhere down the chain and are never recommended.
You can also, at the training time of the model, you can analyze the the distribution of the weights you have gathered and drop the weights that are too small. So if you have one query, like the toy example that we had, and you have something that just has a weight of 9, whereas most of your items have 10,000, 20,000, and you just drop like the 10th percentile or something like this, and then you're on the safe side as well.
So actually, a related question. If you had a competitor who might be scraping your site, what often happens, people, they run these via queries, could they potentially break this system by injecting lots of synthetic queries that... Sorry, I'll give them someone...
Exactly.
just cut that out of the video.
No, we have, yeah, it's also, I think, any sites that of a certain size are also bot protection, so we have bot protection in place as well. Yeah, it's also, I mean, the hackable part, I think it's valid for any kind of machine learning algorithm or model that might be learning on a continuous basis what's going on to your on your website. But it's definitely a possibility. We have also like search IDs. You have search sessions that are generated and things that happen only when JavaScript is activated and so on. So just the true user behaviors are really kept. And I can tell you we've had bots and we are not seeing the effects so far.
Fantastic. Okay, next question. Doug.
You mentioned very briefly about using document frequency to rate the popularity of items. Are you using anything else, and are you using that for queries, just so you're not completely biased for your items and stuff for everything that's globally popular?
We tried it for the products. We didn't try it for the search. So the search is quite recent, but we have plenty of things like this that we want to try. We haven't done any. For example, in this particular implementation that we tested, we did so little data processing that the Rolling Stones is different than the entry Rolling Stones. We have like 10 million queries, and we have a lot of improvements that are planned in order to solidify the results that we show.
Okay, there was a question at the back. I think the next one. I'll come to you in a second. Yeah.
Again, great talk. Thank you. You mentioned that you're using the sessions as sequences to find out, for example, the right spelling, right? To learn corrections. So, did you do anything to filter out data? For example, like if a session actually led to an exit for the user, then the final thing, even if you served some results and if there was not a good interaction on those things, then maybe it's the right spelling or maybe it's not, right? So how did you, for example, filter your data to say this is useful for my model? Yeah.
I think, so we didn't do anything actively, but inherently what happens is if somebody exits after a session, then what they did last, what they did is placed last. And if you follow the sequential rules, then it will get no weights assigned. So over a lot of sessions, this token will drop, or this particular query won't be relevant. Of course, you won't be able to recommend anything for it, but that's. I don't know if it answers the question or sort of. I'll take this as a yes.
I'm very curious. You were showing like example of these game consoles and iPhones, obviously, and these kind of products, they usually have like different variations, right? Because even if you have like PlayStation 3, it could come in different colors, different gigabytes of space, etc., etc. Like, do you do any like sort of grouping of these sorts of products into one when you're trying to recommend? Because, or not?
So what we saw, for example, for at least the product views sessions when we tried with Genzim was, or like the Pro2Vec approach was very good at really staying in this particular domain. Or like if I'm looking at a PlayStation 4 game, I see only PlayStation 4. With this approach, it's the same, but sometimes we see, for example, for a console, like you look at the Nintendo Switch, you will see, for product views, not add to carts, you will see some Nintendo Switches, and towards the end you will see other consoles. So we like these results better in the sense that it also tends to open up variations. And it's always the thing with collaborative approaches is that they really reflect what users do. So at some point you have to believe what the data brings back up. And for some games it really stays, for most of the games it really stays within the platform, PlayStation 4, but on some you can see that there is the Xbox version that's showing up, for example. And maybe this reflects that people went first to PlayStation 4 and then realized they wanted the Xbox One.
Any other questions?
In the last Harry Potter sample, you removed products that match the user query. So, yeah, maybe the other ones are better, but I don't see a way for the user to get back.
No, so if you notice, the result count are the same. So we haven't actually filtered anything. We just boosted the products that the users interacted with.
Okay.
So there's no filtering going on over here. There's just some boosting that we've done. We noticed that because these products were also in the results that returned from Solar, but they were also recommended by the recommendation engine for the query Harry Potter with the single R. So we sort of said, okay, if the recommendation says this is relevant and Solar says this is relevant, it sort of moves to the top of the list because it's very relevant. Does that? And yeah, and the view has only, so basically we've just cropped the view for the top 5 items, and obviously you could paginate and stuff. Does that answer your question?
Yeah, thank you.
Cool, thanks.
Okay. So I'd like to thank our speakers.
Thank you.